This is the final project for CS184 by Alvin, Kehan, Natalis, and Yuto. In this project, our goal was to create a physics simulation engine showing the effects of wind on water. This has two components, creating a fluid engine for the water and then simulating wind forces within this engine. For our fluid simulation, we followed the paper Position-Based Fluids, which uses a particle-based method in order to simulate the physics. The core technology presented in this paper that we have implemented is a simulation loop that adjusts particle positions in order to enforce incompressibility. For wind simulation, we used our own technique of simulating wind through particles traveling along predetermined paths, which are generated according to user-defined functions, allowing for different wind patterns, speeds, and rates of particle generation. Collisions with fluid particles impart velocity, allowing the wind to push the fluid around. Furthermore, we add a realism heuristic of having the wind particle disappear after a certain number of collisions, thus primarily only affecting the upper regions of a fluid exposed to the air. For our rendering, we use the Martian cubes algorithm in order to convert our fluid point masses into a mesh for rendering. For each grid, we calculate the ISO value for each of the 8 vertices to determine whether or not each vertex is in the mesh or not, and thus we can able to construct a unique mesh. Here are some of the basic results we are getting. This is the water we get without any wind involved. Here are some of our results using basic wind. Both very weak wind very gently pushing the surface of the water, and very strong wind shoving very violently against the water. Here are some more interesting wind patterns, such as a circular wind pushing along the surface of the water, exploding it upwards a bit, as well as a pattern with two opposing winds pushing against each other, creating an interesting ripple effect on the surface. Ultimately, we incorporated many fluid dynamics and wind particle physics in order to emulate our water particle behavior under the effect of wind. We also added other features such as acceleration methods through OpenMP and GPU acceleration to enhance our rendering speed. And ultimately, we converted these point masses into 3D meshes to produce visually convincing simulations.